statement about fission or fusion is correct? Okay. Okay. In a fission process, a nuclei breaks and form two different nuclei, smaller nuclei. Suppose this is a one. It's a one nuclei. It will break into two smaller nuclei. So this process is called nuclear fission reaction. And in nuclear fusion reaction, two different nuclei combine to form a heavy nuclei. Suppose these arrows are nuclei, two different nuclei merge to form a single nuclei is called heavier nuclei is called fusion process. And in fission, one heavy nuclei breaks into two different nuclei, smaller nuclei. Okay, so see, during fission means breaking of heavy nuclei into two smaller nuclei. Hydrogen converts into helium. Hydrogen, like during breaking, hydrogen is the smallest element. It cannot be converted into helium. Helium is twice in mass than hydrogen. So this statement and releases energy. That statement is incorrect because hydrogen cannot be hydrogen actually converts into helium by fusion reaction. So this statement is incorrect. During fission, again breaking, like a heavy nucleus break and converts into two smaller nuclei. Uranium converts into daughter products and releases energy. Yes, it is possible. Okay. So, like fission occurs. Fission means breaking of uranium into daughters products and release energy. Like it's possible. It looks correct. Next is during fusion means now two nuclei are going to merge to form a single heavy nuclei. So fusion, helium converts into hydrogen. Like helium, two heliums will merge to form boron. A helium cannot be converted in like the fission of helium can result hydrogen, but fusion of helium can give boron or carbon or like the little heavier than this one. So this statement looks wrong. Okay, now it means C is also incorrect. Now D. During fusion, uranium converts. Fusion means two small nuclei combine to form a heavy nuclei. Uranium is already a heavy nuclei. It converts into daughter. Daughter means breaking. Like the fusion means like two nuclei will give a heavy nuclei, not the daughter nuclei. So this statement is also incorrect. So we have only one correct option, which is B, in which is this one is about related with the So this is the correct option. The input power to a motor is 300 watt. So this is input power and time is 20 seconds. Lifts a load of 400 Newton. This is the weight to a height of 6 meter. Height is 6 meter. What is the efficiency? We need to find out efficiency. So input power is 300 watt. Now let's calculate the output power. Is actually potential energy over time. Potential energy is weight into height over time. Weight is 400 newtons. Height is 6 meters. And time is 20 seconds. So it is actually 120. So output power is 120 newtons. Input power is 300 newtons. So we can find out efficiency is 120 . So it would be 3, it would be 40. So it is actually 40%. So correct option is C. C is the correct option. Okay, now a young child holds a ball over the edge of balcony. Here is a young child which and holds a ball and is standing in a balcony. The ball has a gravitational potential energy because from the ground it has some height due to which it will have some potential energy. The ball is then released. Okay, it falls onto concrete path below and bounces back up. Okay, suppose let's assume, suppose it's a ball. When it is released, it will go like this and will bounce back like this and bounce back like this. So there would be a bounce back. It falls onto a concrete path and bounce back. Okay. Now question is, which sequence represent in the correct order the transformation of gravitational potential energy after the ball is released? Okay, when the ball was released, like initially it had gravitational potential energy as it is mentioned here. So it had gravitational potential energy. Then gravitational potential energy is converted into kinetic energy. So gravitational potential energy is going to be converted into kinetic energy. So this kinetic energy, the second one is this kinetic energy. These two are possible. So elastic is not possible. So these two options are incorrect. So we are going for these two options. Okay. When the ball will hit the ground, then we can see that due to elasticity, the ball, normally the balls are elastic, so that would result some elastic potential energy. So gravitational potential, this option is incorrect. So we have this option and this option, and the ball will move in upward direction. That would be kinetic energy. Motion result kinetic energy. So we have this option. In number 67, how much energy would be released if 1 into 10 to the power minus 20 kg of matter was entirely converted into energy? Again, we can use Einstein's equation E equals mc square, and mass is given, and c is 3 into 10 to the power 8. C is the speed of light and whole square. So 10 to the power minus 20 times 9 into 10 to the power 16. So it would be 9 into 10 to the power minus 4. So this is the correct option. Number 68, the diagram shows a curved curtain rails that have a steel ball rolling on it. The ball is released at point A. Here is the ball from where it is going to be released. At which point does the ball have maximum kinetic energy? Like you can see, this would be the point where it will have, okay, let's assume that this is the lowest point, and at lowest point, it will have a zero potential energy, and whole potential energy would be converted into, sorry, at this point, all of its potential energy would be converted into kinetic energy. So at this point, it will have only kinetic energy and there would be no other energy. That's why we are going to mark this one as the point where it will have maximum kinetic energy. Number 69. The speed of light is 3 into 10 to the power 8. We know it. What is the energy equivalent to 2 kg of mass? You can multiply, you can use Einstein equation E equals mc square mass is 2 kg and c is 3 into 10 to the power 8 whole square. So it would be 2 times 9 times 10 to the power 16. Oh, okay. Like our answer, like this is our one of the answer, and it is similar to this one. Okay. Now you can see 2 is the mass, 3 into 10 to the power is 8 is speed of light, and this is square. So this is the energy equivalent to 2 kg mass. Now let's move to the next one. A mass hangs on a string, like it's a kind of pendulum like situation at point P. Okay, some mass is hanged. It starts from position 1, okay, from, and swings to the furthest position on the opposite side. Okay, suppose it's a kind of pendulum. You drag it from here to here and then release, and then it will start oscillating like this on the opposite position. It then oscillates several times with decreasing amplitude. Yes, its amplitude starts decreasing due to some friction. Like some friction would be here. Here is the point of connection where some frictional effect would be present due to gravity and due to air friction. Damping effect. This is called damping effect. The decrease in energy and decrease in amplitude is actually the damping effect. Okay, where does the ball have the maximum most kinetic energy? We know that, like, if you just compare it, suppose this is a ground surface, and this is the point where the ball will have maximum height. So height means these are the points where it will have maximum potential energy, and this is the point where its height would be approximately zero, and at this point its kinetic energy would be maximum. So this position name is not mentioned. 1, 2, and maybe this one is 3. Hopefully. So, so the first time at position 3, yes. Last time it will have, like, with the passage of time, its speed decreases. That's why. So most kinetic energy will be at position. Suppose let's mark this one as position 3, and this would be